Good evening. My name is Stefan Wellsandt. I work as a research associate for the Bremer Institute for Production Logistics, BIBA, and I'm going to present you a paper about the anatomy of a digital assistant. At first, I want to introduce to you the history of the voice assistant revolution, which is the backbone of a digital assistant. So it started more or less with the initial products published by Apple and Google to do voice interactions with their devices or services. And then over the years, we migrated slowly to these home assistants such as Google Home or Alexa and others, up to the point where we had more than 3 billion voice assistants in use. And in this presentation, I'm going to talk about why is it helpful to have a digital assistant, and in particular in the manufacturing domain. The first kind of problem statement is that digital assistants are amorphous compound technology. Amorphous means that there are no clear boundaries for the assistant. In the illustration on the left-hand side, you see the basic structure of a conversational agent. So what is the conceptual basis of a digital assistant? And on the right-hand side, you see the amorphous part, which is so-called backend, that connects the assistant to all kinds of other information systems in an organization. And in the manufacturing domain, we're talking about things like asset monitoring, manufacturing related analytics, or certain kinds of media that workers need to operate processes, to operate machines and do their daily work. The second part of the statement is the compound technology that we have. Compound means it's a mixture of technologies, and on the left-hand side you see a stack consisting of the server infrastructure, devices, and peripherals. I start with the devices because that's the most tangible aspect that you will realize as a human when it comes to the assistant, and there we have a variety of options how to interact with users. We can use voice and screen to certain degrees, ranging from voice only to screen only and something in the middle. And we have stationary and mobile devices that we can use. Then we have the peripherals, which are an integral part of the solution, because in manufacturing you have to deal, for instance, with noise. You need to have noise protection, and you need to have noise filtering when you want to use a voice-enabled digital assistant. So that is an aspect that has to be thought of when you design and implement digital assistants in your production. The last part is the server infrastructure, and the server infrastructure can be infinitely complex depending on what your application is. And on the right-hand side, you see an illustration of the architecture for our COALA factory assistant. COALA is a European funded research project, and we're coordinating it. So that's what we are building there, based on mainly on open source technologies. And you see the differentiation between the Android device, mobile device, and the various parts of the backend that stay on the server infrastructure. The second aspect of our problem statement is the fact that digital assistants are multi-purpose tools, and as such they share a burden with general computers. So a general computer you can use for a lot of things. Similar, you can also use a smartphone for different things. It depends on the apps and the software that you install on the device that make it useful. And here on the left hand side you see the illustration of the number of Alexa skills from 2016 to 19. There's a steady increase in the number of these skills up to 100,000, and nowadays we probably have something like 200,000 skills for Alexa alone. There are other assistants that come with their own skills or similar skills, and this illustrates that there's a variety of purposes that can be met with an assistant. The second aspect to consider about the multi-purpose tool statement is that we have an increasing number of applications, a variety of applications, and on the left-hand side you see an illustration from an industrial assistant called Speaks that's commercially available also, and there you have functionality like measuring something, calculators, setting timers, getting material for learning, or getting explanations, getting information, getting plans, and so on. All these kind of small features that you can use at work to simplify or speed up certain tasks. The last part about the multi-purpose tools is about the deeper real-world integration of assistants. On the left-hand side, you see different skill types for Alexa, and there are a couple of them that require or benefit from real-world integrations with real devices in your environment. There's automotive, for instance, which is very obvious, but there's also entertainment, there's networking and Wi-Fi, smart home energy and security. All of these connect somehow to smart devices in your environment, and through these connections, through these integrations, the assistant becomes more and more useful and can do more and more things also. The goal and scope of our paper was to summarize the benefits of business-focused digital assistants with an emphasis on manufacturing. The results, we believe, may be helpful for assistant designers and decision makers in companies assessing whether an assistant is a suitable tool at work. Our approach has 3 steps. The first one is to outline a state of the art for digital assistants. Here we tried to be a bit wider than manufacturing because there are simply not so many implementations of digital assistants in manufacturing yet. Then we tried to define a use case to clarify the challenges in manufacturing. And afterwards we identified benefits and connected them to technology and the challenges above. This slide presents the use case characteristics for production environments that we identified. They are not exclusive for production or manufacturing, as other business processes share similar characteristics. The first one, and maybe the most obvious one, is time pressure to meet performance goals. But also a second one that is very obvious is that in order to do the work, you need skills and competencies. If you don't have those, you need to do costly vocational and on-the-job training, sometimes for days, weeks, or even years. And beyond that, you also have continuous learning. Employers often use costly shift systems to address fatigue and recreation of workers. So that is something that also many factories that run 24 hours a day must address or must have. There's a need to access information about machines, products, and processes. Not for all workers, but for many workers, there's this need that they have to access certain kinds of information. And there's time-consuming data processing and analysis for specific information. So when you're in need of a certain kind of report, then there is data processing and analysis involved. Time-consuming learning of softwares, user interfaces is another aspect. So when you have a company that is probably larger also and has a lot of different IT systems running, then these ones do not share the user interfaces necessarily. In the contrary, there are quite different user interfaces for each software used in the company. And then also interruption and delay tasks are typical when people have to move to a suitable computer to use software. So when you don't have a mobile device, then you need to move, and sometimes you need to switch between the shop floor and the office, and sometimes you might even need to change the building for that. In the paper, we identified 10 benefits of digital assistance in manufacturing. I'm going to present you 2 in this presentation here, starting with central access. By central access, we mean that the assistant interfaces multiple information systems in an organization and becomes a central access point to these systems from the user's perspective. The users can access the assistant via one or more personal devices, and central access minimizes the learning of different interfaces, and if the devices are mobile, then the workers can also avoid moving between workplace and a suitable computer. The second benefit is permanent accessibility. Literally speaking, this means that the assistant has no downtime, which is not entirely true because there are technical preconditions and limitations. For that, please refer to the paper. Users can benefit from permanent accessibility because they can access or request support from the assistant anytime. At the same time, the assistant can communicate whenever it's necessary via the push principle, so the assistant knows something that the user does not and informs the user proactively. An example for the permanent accessibility is the so-called augmented data analytics, where we combine data analytics with conversational AI, for instance. And there, users can ask the assistant, for instance, to perform root cause analysis anytime a factory system fails, and the assistant can immediately respond, perform the analysis, and report the result. There's no need to wait for an expert or for someone to do the analysis. The outlook has two parts. First, there's a need for more experiments in natural work environments, which is necessary to explore and experience the factors that determine digital assistance use. There are aspects such as trust in AI systems, impacts on teams and individuals, training and education, and capabilities of open and closed technologies. So one of the early questions we asked was whether we would entrust business data to an Alexa device. Our first prototype started with Alexa, but then it turned out that we do not understand a lot about Alexa, how it works. We cannot see into the technology behind Alexa because it's closed and because it's behind a curtain of business models also that we are not really understanding, the business model from Amazon in this case. So therefore, there's more research and practical work needed in this field. The second aspect is about clarifying disadvantages and limitations of digital assistance. There is an inherent risk, for instance, that workers lose their autonomy if they are working with probably even more capable assistants, digital assistants. There's also a need to understand that there are technological and designed limits of understanding language. We are not trying to build a universal general AI that can understand every single utterance that we provide. There are designed limits. There are also technological limits that continuously move. And there's also a case where producers can become dependent on the assistant. If the assistant takes over a lot of critical tasks because it's simply much better than humans, then there is a dependency. And finally, like all information and communication technology, assistants also pose a security risk. There is a chance that an assistant can be used for espionage or can be corrupted and cause the damage of property or health. Thank you for listening to this presentation. You can get in contact with me after the conference via email, or you can visit our website for our COALA project where we build a digital intelligent assistant for manufacturing.